Hello and welcome back. In this video, we're going to talk about basic Git operations. So since we are following the official exam topic, this is going to be the first topic in the first module of the official exam blueprint. So the module is network programmability foundation, and the first topic of it is about version control operations such as git add, git clone, push, commit, diff, branching, and merging conflict. So obviously these are not all the git operations, but these are the ones that the exam wants you to know. Also, we'll go over some other rather operations and semi-advanced topics of Git in future videos. So the first one is Git add, but we're not going to follow this order because I figured this order is a little bit off. Rather, we'll do something on our own. So let me collapse this, go here. This is the repository of this course. If you want to access the codes that we demonstrate throughout the videos and throughout this course, then you can access it from this URL over here. And we've already published module 3, but the reason I'm showing you this is, first of all, you would know that this repository exists. Second, and it's also public. So the second reason is that I want to actually do something with this repository. I want to clone this repository, basically download it locally on our machine. So I'm in my Ubuntu machine, and this is WSL, and I'm gonna hit ls. And what I'm gonna do is go here again, and there are several ways that we can pull a remote repository. But the most common way is to use HTTPS and use this method. There's also the SSH method and the GitHub CLI. But this method is the most common one. I'm going to copy the Git URL, and this is different than what you see here. As you can see, this one has a Git extension. So back to my terminal, and I want to show you the first Git command that we're going to use, and that is git clone. By the way, you have to have Git installed. This is usually not pre-installed on your system, so you have to install it. So I'm going to say git clone and just copy that URL. And the moment I do that, it is going to start pulling that remote repository. And there's also a progress bar or some kind of a percentage that shows the progress of downloading or fetching this repo. So the moment I do that, this is a very short repository, so there is not much code in it. And as you can see, it is cloned. So if I change my directory to DC Auto, the moment I do that, you will see that the prompt would change to a Git repo prompt. This is indicating that this is a Git repository and this is the branch. So if I said Git branch, this is the main branch, and this is the only branch that we have. There is no other branch. And since we have an asterisk here, this shows the current branch that we are in. And that's it. That was the first command, git clone. And the next one is git add. So let me see what I have here. I have module 3 because we already published module 3. Now let me create a directory, call it module 1. And if I say git status, there is nothing showing here because we just created an empty directory. So if I change to module 1 and touch a file, something like readme.txt, as you can see, there's a cross showing indicating there is a file that we haven't staged yet. Now if I say git status, you will see that this current directory is not staged. So the way we can stage a file or even an entire directory is by saying git add. And if I say dot, it would stage the entire directory, or I can say readme. But I think it's better to do git add dot because we didn't stage the directory itself. So if I say git add and say git status one more time, you will see the output, the difference in output between this and this. This one is saying you have an untracked file or files. This one says this is tracked or staged, but we haven't committed that yet. So the way we can commit that is by saying git commit. I'm going to use the M flag for message. So each time we have to, if you're working with the Git CLI, you have to provide a message for your commit. If you're using the web interface, you don't need to do that. And I'm going to say just message. And it is committed. And also the cross sign is gone. So we know that this is committed. But now if I go back here, if I refresh the page, you will see that module 1 is not showing here, and that's because we haven't pushed it yet to the remote repository. And that would lead us to the next git command, which is push. So the way you can do that is by saying git push, and I'm going to say origin, give it a name, and main is the branch. If I do that, it wants my username, and I'm going to put in my username. This is the GitHub username and password. So if I go here and here, this is the password for my GitHub website. So if I do that, paste, enter, it says support for password is basically end of life, and after this date, password authentication is not supported anymore. But what is supported is API token, or GitHub calls it a personal access token. Again, I'm going to say git push origin main and put in my username. And instead, I'm going to go here. I'm going to go to settings, developer settings. And if you expand this, personal access tokens, or PAT in short, I'm going to use tokens classic. And since I've already generated this token, it's not showing it to me anymore. So I've already pasted it somewhere safe so I can use it. But if this is your first time, a token would appear here, and you just have to copy that somewhere in your in a text file or somewhere safe. So I've already done that, and I'm just gonna paste that here instead of password. So there is no indication of saying token or personal access token. This is the same place you have to put as you would put your password before. So I'm just gonna copy this path, paste it here, and it says it is pushed from the main branch to the main branch. And if I go back here, not settings, rather my repositories, DC auto, and you see that this directory is appearing here, and we should have a readme file. There is nothing in this readme file, but we are going to do something with it. So that is another git command that we went through. And the last one is git diff, like that, git diff. So with git diff, the idea is that it is going to show the difference in content between our current working directory and our index, or GitHub repo. It is similar to Git status, but it's not going to just show us the content or the files and directories that need to be staged. It will also show us detailed difference between content, between actual code or text. Let me show you what I mean. So here I have a README file, and I'm going to echo something out and put it inside this README file. I'm going to say this is just a test and redirect the output to README txt. Now, if I cat that out, you will see that we have a content. If I say git status, it is modified. This file is modified. And if I say git diff, it shows that this is something that's added. This is just a test, is the new content for readme txt. Now, if I try to echo something else, maybe this is, or say something else, redirect the output again, and this will override the output. If you want to append, you use double basically anchor tags. Now, if I say git diff, it says that something else is added. And if I say git add diff again, now there is nothing showing here. That's because the file that we staged is exactly the same, in the same shape as the file that we have in our current working directory. So current working directory is equal to our index, git index. Now, this was something that we added to basically git tracker. Now, if I try to echo something else out, something else too, this one is a little bit different. As you saw in the previous output, there was no indication of removing anything. It was just a minus sign indicating that an empty file was removed, but we actually had content in it. And that was because we had not staged that content at that point. So let me show you again what I mean. Now, if I say git add or git diff, now that's the difference. The last time we made a staging, or we added the file into index, the content was this. Now it is this. So the reason that it was not showing here in the previous output was because we had something in the file, which was, I believe, this is just a test. We can also double check that. Not sure. This is just a test. But we just added this into README, but at no point, as you see, we added the file into index. We did add here, and that was actually when the content was something else. So that's what I wanted to show you in this video. I will see you in the next one. Okay, here we are. I'm in my Ubuntu WSL, and I am in this directory called Git. If I do ls, I don't have anything here. So let's make a directory. This is fine. Make a directory called project, and I'm going to change the directory into project. If I do ls, I don't have anything here, but I want to make this directory as a GitHub repository. So in order to do that, I'm going to say git init. This is going to initialize a Git repo inside this directory. So this is not a directory anymore. The directory is project, but repo is git master. But if I say git branch, as you can see, there is no branch showing. So the reason is that we have to always create a file, commit that file, stage that file, then commit that file. That way, the branch will be created. So let's do that. I'm going to create a file called test.py. And as you can see, there is a cross sign here. That means there is an ongoing, let's put it this way, there is a modified file that I haven't committed yet. So if I say status, git status, untracked file, test.py is not staged yet. So we have to stage it. In order to stage that file, I'm going to say git. I can say add and the name of the file, right? But you can also say git add the current directory. I'm going to say stage every file that I have in this directory. So I'm going to do that. And if I say git status one more time, the color is changed to green, meaning the file is staged, but as you can see, we have also this cross sign here. So that means it is not committed yet. There is a file that is now staged, but it's not committed. If I say git branch, there is also still not showing here. So I'm going to say git commit, and I'm going to call it maybe first commit. And now the cross sign is gone. And I have a committed file. If I say git branch one more time, I have now a master branch. So let's do something else now, because we're talking about merging different branches. So I have to create another branch, git branch, and I can create branch number 1 like that. I can do that. This is fine. It'll create a branch for me called branch 1. And if I want to check out that branch or go to that branch, I have to again put another command, say git checkout branch 1. But I can do one more thing, actually one thing instead of issuing 2 commands. Once creating the branch, then changing into that branch. So instead, I'm going to say checkout. But if I say checkout br1, it says that branch doesn't exist. I can say -b for branch, git checkout br1. So he's going to create that branch for me and basically change our branch as well. So let's do that. And now, as you can see, we are inside branch 1. If I say git branch, now I have branch 1. I don't have to commit anything here. And the asterisk sign indicates we are in branch 1. So I will do something here. I will open up my VS Code, open this repo from VS Code, and we'll see from there. Okay, now I am going to open a folder because I'm dealing with a Git folder or directory. And let's see what we have inside the Git directory. I have projects, so let's see what happens. It opened that for me, and also, as you can see, there is this version control here, right? The version control says, okay, let me check if I have, yeah, I am in branch 1, and I also have the master branch. So I'm in branch 1, but I don't have any file here. So I go here, create a file. Actually, you know what? I am going to check here. Yes, I have already a file. Now, test.py is here, but it is an empty file, of course. Now, what I'm going to do here is I am going to write something here. Print, this is test1. Save it. And as you can see, there is an ongoing change that is not staged yet. So it hasn't staged it. I can stage it from here, but let's work with the command line, because in the exam, you should be very comfortable with Git commands. Of course, you can do everything from your VS Code, from your PyCharm, but it is better for the sake of the exam to work with the command line. So I can do something here. I can say git now add and git commit I'm gonna call it maybe second commit. It is now committed, but it is committed inside the BR1 branch. If I say git checkout to check or check out the master branch or change my branch into master, now as you can see, the content is now gone, right? But again, keep close attention to this section here. If I say git checkout this time BR1, now the content is appearing one more time. So again, I will check out master, but what I'm gonna do here is say git merge into BR1. So I'm going to introduce BR1 changes into the master branch. As soon as I do that, as you can see, I'm in the master branch. So if I go here, I'm in the master branch, as you can see, and also it is now, the change is now introduced into the new branch. So in the next video, we're going to talk about how to resolve conflicts between these two branches. Okay, in the previous video, we talked about how we could merge two branches, right? So for the sake of this video, I had to unmerge these two branches because we want to create a conflict, then merge them again to raise that warning from Git that tells us you have to conflict or resolve your conflict first, then try to merge these two branches one more time. So I had to again unmerge, then make some changes in this video, then try to merge one more time. So if I say git, now I'm in the BR1 branch. If I say checkout master, as you can see, the master branch has something extra. So again, the BR1 branch doesn't have anything, so you know that this is not merged. These two branches are not merged. But let's do something. I am going to, in the BR1 branch, print maybe call this test3, save it. I'm gonna say git add, not like that, git add, git commit mass. I'm gonna call this mass or BR1 commit. Now if I check out master has test2, right? So if I want to merge, if I say merge now BR1, look, it says fix conflict and then commit the result one more time. So if it didn't have VS Code, we had to do something about that manually. But fortunately, if we have VS Code, I believe in PyCharm, definitely have to have something like that. So you get the idea, right? When you have conflicting results or conflicting merges, that means you try to make changes to the same file in two different branches. Let's call this branch 1 and branch 2. You made some changes in branch 1, try to commit it, you did commit it successfully, then you had some commits, different types of commits in our case master branch, let's call this BR2, branch 2. But if you want to merge, that's a problem. In the previous video, we successfully and easily could merge these two branches because we only made changes to the file from only one of the branches that we had and not two of them. So let's see how we can fix this problem. Let me actually minimize that. Look, VS Code tells us that I'm going to accept current change. So when we are accepting current change, where are we now? We are in the master branch, right? If you're in the master branch and accepting current change, this is the current change. So look at the head. The head is pointing to the one that is sitting in the same repo or branch, sorry. This is the current change, and the current change is the one that belongs to the current branch, which is the master branch. So it says you want to keep test2 or accept incoming change from BR1. Also, we can accept both changes. So if we accept both changes, it's going to append both changes, right? Append them to the same file. Also using the git diff command, or it is integrated into this kind of one-click feature that we have, we can compare the changes. So I believe I don't think there is anything showing here anymore. Yes, this is lacking, and this is the thing that is being added from the other branch, right? So instead of seeing the changes, we can, let's do something. I am going to accept current change, or let's accept, it doesn't matter, maybe accept both changes. So I'm going to accept both changes, and it is going to append test2 and test3 together. Let's see, accept both changes, and there we go. If that was the other way around, maybe accept incoming change, test2 will be deleted. There we have it. So I can save it. So we accepted the incoming changes from the BR1 branch, and we deleted the one that was in the current branch, the master branch. So what I have to do here is I am going to stage this file, because otherwise, let's do something. I'm going to say git merge br1. It says you have not concluded your merge. Commit your changes before you merge. So the problem is we have to stage our file either using this icon here or using git add command and commit our changes first, then try to merge it one more time, because right now it's like we didn't do anything. What we did was the changes we made belong to the current file. We haven't put it inside, we haven't changed anything in the version control, in the source control. What we did was changed the file inside our text editor. So I'm going to stage it, commit it, and I can now easily merge these two. So we issued this command git merge master from branch 1. We try to merge into the master branch, and right now we don't have any problem. So if I go to master, we have it inside the master, the same content, but I'm going to do something in the BR1 branch. Since we are in the BR1 branch, I am going to say test4, save it, and if I stage it and go to master, as you can see, the content is still, the content was reflected into the master branch. So this is the master branch, now this is the BR1 branch. I can commit it if I want, or maybe add print test number 5, save it. If I save it and go to master, as you can see, there is even no need to stage the file, because if you don't want to commit it, there is no need to do that. Whatever you do inside whatever the branch is, I can also say, just add one more thing here, number 6. Even from the master branch, I go to BR1. Either way, it is going to work. So it is going to work both ways. The changes in the BR will reflect into master and vice versa. So that was the end of this video. I will see you in the next one. Okay, in this video, we're going to talk about more Git features. The first feature I want to again take a look at is the checkout feature, or the checkout command. But in the previous video, you saw that we used the checkout command to check out a specific branch or change our branch into another one, or we could create a branch and check it out. But there is also another thing we can do, and that is something like doing Control Z when you undo your changes inside your file, not the version control. So I'm going to close this because we're not going to deal with that at this moment. What I'm going to do here, make some changes to this file. So I can delete this line, save it. So maybe I realized it was a terrible mistake and I could technically do Control Z, but when you're working with Git and you are working on a real project, it gets more complicated than that. So what I'm going to do here is I'm going to undo this change. I'm going to say Git, there we go, Git checkout test.py. As soon as I run this, the changes will appear here one more time. But again, this has to do something with the content or the content of the file itself inside my environment, inside my text editor, not the version control. We are not staging, unstaging, we're not doing anything with the version control. Rather, we're just undoing what we were doing before or what we had in the file before. So let's do something else. I'm going to open this. Now, maybe add, I don't have any changes here. Maybe say 5, right? Save it, right? And I want to stage this change. I can obviously use this or say git add everything. I can do that as well. And currently, I have one staged file. What if I want to reset this staging? Well, the command I can use is git reset. I'm going to say git reset and specify the head to be, and also in this case, I'm going to say test.py, the name of the file. Say reset this file, or kind of say undo the changing. If I run that, again, I have one more pending file to be staged. I don't have more than one file here, but if you had more than one file and you wanted to unstage everything, the command would be git reset, specify the head, and dot, which means everything, every file that I have in this current directory. And the last one, the last feature we're going to take a look at is called git revert. So with git revert, you're allowed to go back to a very specific commit that you made in the past, right? So I'm going to say git log to learn about the commits I made. This is the latest one, and I have all these commits. Now, what I'm going to do is I'm in the BR1 branch, and what I'm going to do is copy the commit hash and go back to this specific commit. For that, I'm going to say git revert head, paste here. A text editor pops up. I'm just going to exit out of this. And yeah, so we have merging conflicts. Maybe I picked the wrong one. But as you can see, we went back to the specific commit. So let me accept incoming change. Yeah, apparently that I didn't even remember what was the commit because we made so many commits during these videos, but this is what it was before. So I can also stage it with merge conflicts. Yes, I'm going to stage it, doesn't matter. Commit it, save all, and commit changes. And this is my new content in test.py. Also, the branch, as you can see, is BR1. So that concludes this particular video. I will see you in the next one. Hello and welcome back. In this video, we're going to talk about exam topic number 1.2 here, which says describe characteristics of API styles, REST, and RPC. So we have more API architecture styles other than these two, but the exam wants us to know about REST and RPC for the purpose of automation, network automation. So since it says describe, then it is theory, and we're going to talk about this on the whiteboard. So I'm going to say here REST and RPC. So let's start with similarities. Let's understand the similarities between two styles first, then we talk about the differences. So the similarities are, one of them is abstraction. Abstraction. And what I mean by that is both API styles, both of these frameworks would provide abstraction for the developer in a way that the developer um, doesn't necessarily have to know anything about underlying operations and underlying system. They just have to know some standards to be able to talk to this application through either endpoints, REST API endpoints, or if you use RPC through functions. So abstraction is a similarity. And they're both HTTP based. HTTP based. And you might not know this from before, but they're actually RPC uses HTTP, and RPC uses post request only, but in a different way. So it's not like a post request in REST. The architecture and functionalities are different. We're going to talk about that as well. But they are both HTTP based. They both use JSON or XML for the DSL, data serialization language. So RPC was more leaned towards XML, but in the recent years, JSON is highly adopted in RPC output as well. And both would support any language. Meaning, if you use Python, you can work with REST or RPC. And if you use, I don't know, JavaScript, same thing. If you use Go, again, it doesn't matter. You can use both REST or RPC, any application that provides these APIs using any programming language that you want. You just have to follow a specific guideline and a specific set of operations, provide things like authentication, the right coding syntax, and so on, to be able to invoke these APIs. Now, we talked about the similarities. Now I'm gonna talk about the differences. Well, there are a number of differences between these two, and when it comes to RPC, we are going to, well, RPC stands for Remote Procedure Call, meaning we will invoke some functions or call some functions on a remote server, as if that particular server is local. So we call procedure also function or method as well. So when we say we invoke a procedure, in other words, we can say we invoke a function or a method. And again, we invoke that specific function as if that, well, earlier I said as if the server was local, but as if the function was local, right? So you can kind of work with that. Well, the function is remote, and we're going to call that through RPC, and we basically perform some tasks. And I will talk about what types of tasks are most suited for RPC and what types of tasks are more suited for REST. With REST, So I can probably say something here, RPC remote call. And with REST, we deal with resources and objects. So we try to um, modify or basically make changes to a resource or a remote server. With RPC, we don't necessarily make changes to the remote server, but that function is made through a remote server. So the function is residing on a remote server, then we use that function. With REST, we try to make some modifications on a remote server. So I'm going to say specific data operations. I'm going to say data op on a server, or you could say remote server, but I'm not going to write that. With REST, the actions are limited to HTTP verbs such as get, post, patch, put, delete, and so on. With RPC, the actions are limited to the number of functions that that specific API supports. Because again, with RPC, we deal with functions or procedures or methods. For example, we try to, let's actually come up with an example in the end, but you get the idea, right? REST is, so I'm going to say HTTP verbs. And here I'm going to say functions. And it is probably a good idea to grab these and maybe put them here. Another difference is REST is stateless, meaning the server doesn't keep track of clients' requests. Meaning, if the client sends 5 requests, there is no function, or basically there is no way that the server is keeping track of each individual request from the client because of the way that HTTP behaves, right? HTTP is end-to-end, unicast, and it is stateless. So meaning with each request, we have to provide the full information for that specific packet to be sent over the wire. For the next one, again, next one. If we have 100 requests sent from the user client, then each request has to be isolated from the other one, and each request has its own set of information. And again, the server doesn't keep track of the data that is inside those packets. But there are some things like sequence numbers and so on that the server would use to, or basically this TCP would use. And if you have a TCP server, then again, we can say the TCP server would use to keep track of the packets. And basically that way we can understand if one packet is missing or not. But that's more of a TCP thing, not really about data. And we're talking about data right now. With RPC, it could be both stateless or stateful. So it really depends on the design. Stateful. And that's it. These are the main differences between these. Also, let's talk about when to use which one. So I'm just going to write that here. And we're going to use RPC for complex operations. Complex operations, such as if we want to use some kind of a machine learning algorithm, Or maybe if we want to do banking transfer. Or maybe if you want to deal with anything that's complicated, right? Maybe taking a picture on a remote device or start recording something on a remote device, a remote server, right? IoT maybe. With REST, the operation is simple operations. And basically, whenever we want to retrieve something from a database, maybe retrieve some IP addresses, retrieve IDs, retrieve name, first name and last name. We want to delete something from the database. We want to update or kind of modify something from the database, right? Or we want to add something to the database, right? We're going to use REST APIs and basically design REST APIs for the user or the developer to work with. Let me tell you something else. With REST, you know that we have the HTTP verbs. With RPC, what we do here, let me actually give you an example. And I'm going to say RPC here. And imagine we want to add something to the database, maybe add a product, right? Let me write that down. Add a product. So with RPC, the way we do that is we call a post request. Let me write it down. Post on a specific remote function. So as you know, RPC is again on top of HTTP, just like REST. But so we have to use some kind of a verb, some kind of an HTTP operation to be able to do something. But with RPC, the only verb that is available is post. So the way we do that is we always use the post request on a remote function. Let's say we're using a post request and want to add a product. So we call this post on a function. Maybe it is called add product. And you have to know, so that's the thing about RPC. You have to know these functions, these remote functions. With REST, we don't need to do that. We don't need to know that. We don't need to know any function. We just use the original HTTP verbs, get, put, and so on. With RPC, we have to know the function that is available. And yeah, that's how we do it. With REST, it is still post, but we have to target an endpoint, an HTTP endpoint, a URL. A URL is a longer form, but the endpoint is the basically the last piece inside the URL. Maybe it is called products, and it's usually like that. And the way we do that is use different verbs for different operations inside products. So we don't have to be specific. So the endpoint is not usually this much specific. It is more broad. For example, we have an endpoint here that says products, and this time we're using post. And the next time we want to remove a product with RPC, again, we have to send a post request, right? Maybe something like delete product. With REST, this would be the delete verb, but it could be inside the same endpoint. And the output could be in JSON and XML for both of them. And this is what I wanted to show you in this video. So that concludes this particular topic. I will see you in the next one. Hello and welcome back. In this video, we're going to talk about the differences between synchronous programming or API call and asynchronous API call or programming. This is another exam topic, 1.3. describe the challenges encountered and patterns used when consuming APIs synchronously and asynchronously. So it is focused on APIs, but it is also about code. So whatever we're discussing here is going to be related to both API interaction and invocation, and also any other um, code writing, basically software writing. So we're going to talk about the challenges for each one, for sync and async, and also patterns that we want to use, again, for both sync and async software. So we're going to go to a whiteboard, and I'm going to start with synchronous programming. And here I'm going to write challenges, and we'll start with some challenges, then we get to the patterns that we want to use. So if we are using synchronous programming, or basically interacting with APIs using synchronous software, we're going to have a few challenges. For example, the first one and the most important one is blocking calls. And with synchronous, keep in mind that it is serial. So the communication is serial. That means one step at a time, one speaker at a time, one thread or task at a time. We have to wait for this task to be completed so we can get to the next task, and again wait for the next task to be completed, again go to another task. This is synchronous software or programming. And when we do that, then if we have other basically tasks, those tasks should wait in the line for the active task to be finished, and that would block some calls. So as a result, we're going to have all those tasks waiting, and also we're going to have latency. So with challenges, we really mean problems and complexities. There we go. And also, there might be other stuff as well. For example, scalability is another issue. And since it is very limited to specific calls at a given time, then we can't really scale our code and application. And we have to consider proper error handling as well. So let's talk about patterns that we want to use. And we can use, for example, the retry logic for handling calls. If we have any problem, if we have any error thrown at us, then we can do retry logic. We can also stack it with exponential backoff. And exponential backoff is more of an intelligent way to do retry logic. With retry, we just simply retry our calls. With exponential backoff, we try to double or triple the amount of wait between each call. So with retry, every time we wait for a certain number of seconds, maybe 1 or 2 seconds between each request. But with exponential backoff, the first time we might wait 2 seconds, the second time we might wait 4 seconds, and then 8 seconds, and so on, right? Then timeout handling is another pattern that we can use, timeout. And we can do timeout handling as well in case the request timed out. And this is another form of error handling as well. And we can do circuit breaker. And with circuit breaker, we will monitor the healthy instances. And if the healthy instances became unhealthy, we would know about that. Actually, the load balancer would know about that. It is more of a cloud networking thing. the LB would know about that, and it would cut down the flow of packets, basically the path to that specific unhealthy instance. So it works as exactly a traditional circuit breaker in electrical systems. If the LB or any other server that is responsible detects an unhealthy instance, we're going to cut down the flow over to that instance, and we just send packets to the instances that are working and are healthy. Now it's time to talk about async programming, or basically API handling. So async, as opposed to serial, it is parallel, meaning we are going to concurrently talk to our server. And it just gives you the illusion of concurrency. It's not really concurrent and simultaneous, just like in multi-processing or multi-threading. It just allows for non-blocking calls to work. For example, we have a task here, right? But it encounters a wait time, right? This task needs to wait for a response from another backend service or any other place. As soon as we detect a wait time, the other task would start working, right? And maybe this goes further up until here. Then again, at some point, this would encounter a wait time. Then this one would continue again. Maybe it gets further. So you get the idea, right? We are not really utilizing all the threads or processes that we have. With processing, we're going to utilize the CPU cores, and depending on how many CPU cores are active and running for that specific application, all those jobs are running simultaneously. With multi-threading, it is the same thing, but it happens inside a CPU core. We're going to use different threads inside a single CPU core, and basically the process is isolated to that specific core with multiple threads. With multi-processing, things are a little bit different. We don't have the isolation, or actually it is also isolated, but it belongs to different processes. But so the isolation happens at a different level. There we go. Now let's talk about the challenges of async programming, basically the problems and complexities. One of them is it is extremely complex to write an async software. If you use Python, if you use async IO, it is actually very complex and cumbersome to write a async program. With multi-threading and multi-processing, it is way easier. We have libraries for that. Also for async, we have a library. Async IO is a library, but the way it works is very unusual and hard. And also, well, you get used to it, obviously, but at the beginning, it might be harder. And we have the problem of error handling. And because we're sending a lot of requests at a given time to our endpoint, detecting errors are very difficult. Also, debugging is another problem that we have, and debugging is also a challenge. Debugging is very complex as well. State management, another challenge. State management, meaning we are not sure about the current stage of our communication with the server, because everything is happening so quickly, and we might have unexpected behavior. And we can talk about patterns to use. And we can use, for example, callbacks. Or if you use Python, we can use async await. If you use JavaScript, then that would be promises and promises in JavaScript. And in Java, I think we have futures. So I'm not really familiar with Java. Uh, and event loops, again, with JavaScript, to keep track of our asynchronous communication, the events that are happening. So it gives you a better way to handle the communication. And this is what I wanted to show you. And this is the end of this video, and I will see you in the next one. Hello and welcome back. Now we get to exam topic number 1.4, which is about Python. So they want you to know about data types, functions, classes, conditions, and looping. And I'm just going to tell you what to do. Because we already have this content on the website, I cannot re-record them again. So you have two options: either watch our content on the website or go elsewhere. W3 School, YouTube, basically Python is everywhere now. You can learn it from basically anywhere on the internet. And there are tons of examples. And this is what you should do. So based on administration decisions, I cannot, again, re-record these contents one more time, although I would love to, because I once was a Python instructor for nearly 2 years. So that is it for this exam topic. I will see you in the next one. Hello and welcome back. In this video, we're going to talk about another exam topic, Python virtual environments. So this is another one, 1.5. It says, describe the benefits of Python virtual environments. So the idea is very simple. There is nothing complicated about it. And basically the reason we use virtual environments is that we want to isolate our packages. We want to isolate our packages from our global environments. So you might ask, why do we want to isolate our packages? Well, the reason is when you are developing something, when you are writing code or basically developing some kind of an application, or even if you are working with APIs, anything that is related to dev, you might see some package conflicts. There are some applications that work with a very specific version of another application. But if we don't have that, or have a different version, then we might have package conflicts, right? And there is going to be a number of different weird behaviors and basically complications that might happen if we have everything inside a global space. So there are a number of options that we have with Python virtual environments, and the most popular one is the built-in venv, stands for virtual environment. And we also have the option of conda. This is third party, you have to install it. Then there is more, but there is also another one called virtual env, I think. But venv is by far the most popular one. And this is going to be the one that we're going to use in this video. So I'm going to go to WSL here and expand. So the way we can create a virtual environment is by typing two commands only. But let's do something. I'm going to say pip freeze, and it is going to show me all the Python packages that I have. If I do that, since I'm in the global environment, you will see that these things are installed, and I have already installed them in my global space. Now let's create a virtual environment. I'm going to go to DC Auto, And I'm going to cd into module 1, or doesn't matter, I can stay here. So I have two folders. I want to create another folder, but this folder is going to hold basically keep the virtual environment settings and configurations and scripts, right? This is different. So this is not going to be with the command mkdir. The way we do that is use Python or Python 3, depending on your OS, -m for module, and we're going to use the built-in venv module, right? So far we're using Python 3, m is for module, and venv is the tool that we're using. This is just a tool. Now, we want to create a folder. There are some conventions, there are some popular way to do it. And one of them is using, again, venv. And this is going to be the name of the folder. Some people want to make it a hidden folder, and they would put a dot before that, right? Another naming convention is to use env, .env, or env. So both of them are popular and conventions. Because we want to isolate these two, kind of don't mix them together, we're going to use a different name, and we're going to make it a hidden directory. Now, so far, nothing has changed. The only thing that's changed is that I have this folder inside this repo. If I say ls, you won't see it. But if I say la or lsla, it shows me env, and I can cd into it, cd into env, and we're going to have a lot of things inside this. These are just folders. If you go to these folders, for example, go to bin, say ls, we have a lot of configurations. So we shouldn't be working with this directory. We shouldn't put any file, any script into this directory. This directory is purely to hold virtual environment configurations. And you can put it anywhere that you want in your system. It doesn't matter. For example, when we start activating this venv, you will see that wherever we go in the system, directory, file, whatever, as long as that venv is activated, then we are inside a virtual environment regardless of the path, or basically the working directory. So the way you activate that is by saying source, the name of the directory, bin, activate. And in fact, if I go to env, go to bin, just like we did, ls, there is an activate script here. And by saying source, again, env, I have to cd back, something happened. Source env bin activate. Or if you were inside that directory, if you were here, I could just say source activate. That's it. But since I just wanted to show you the proper way, usually you don't go into the bin folder inside the env folder to activate it. But if you happen to find yourself in there, just say source activate. We just want to get to this script however you want, by specifying the full path, or if you're inside the working directory, you could just use the script name. Now we are here inside this folder. I'm gonna say source env bin activate. And as soon as I do that, you see that the virtual environment is activated. And we have this kind of prompt here. So if I say pip freeze, I don't have any packages inside these environments. Now let's do something. I'm going to pip install rich, and in fact I already have rich inside my global environment, but I just want to show you that if we install anything, it wouldn't be reflected onto the global environment. I'm not sure what I can install that I don't have inside my global environment, but whatever I do is not going to be reflected over to the global environment, and vice versa. Whatever I install in the global environment wouldn't be reflected into any of these. And you can have multiple virtual environments at the same time, and that's one of the reasons that you would put these configuration folders inside your relative folder. For example, we are working on the DC Auto course, and we put this folder inside the DC Auto folder. That means it is going to hold any module that we need for code demonstration, or basically this course only. If I have another folder, I will go to that folder and create another virtual environment for that. And it could be the same name. You don't have to change the name. As long as they are not in the same directory, you could use the same folder name for each virtual environment. And the way you can deactivate your virtual environment by saying deactivate. And as you can see, we are out of the virtual environment. Now I can say source activate one more time. And by the way, the progress is saved. For example, you are inside your virtual environment, you've installed 5 packages. You shut down your PC the next day, you log in to the terminal again, or basically open up the terminal and try to work with this, try to work with your project one more time. Again, because if I kill the session, the virtual environment is also deactivated. So every time you open up your terminal, you want to work with your project, you start from the global environment, not from the virtual environment. Then if you say source activate, it is going to activate that specific VEN for you with all the changes and configurations and packages that you had installed before. So the progress will be safe. You're not going to lose your packages every time you kill or deactivate the environment. Also, I can open up VS Code here. And with VS Code, it is a little bit inconsistent. So sometimes we are starting from the virtual environment, sometimes not. Because we are using VS Code terminal, and it is another session from whatever we had in our, in the other environment we were working with. This is just another terminal, meaning another session. So obviously the virtual environment is not activated here. I can just say source and being activated one more time. And we are here. Now I can say deactivate and deactivate it here. But from the other side, or was it from the terminal perspective, it is still activated because it is another session. Now, there is another way if you use VS Code or PyCharm or any of these fancy editors. There's also a GUI version to do that, but with VS Code, it is very inconsistent, and sometimes it works, sometimes it doesn't. I always use Terminal. It is very simple and very convenient. Each time you would know that it works. With PyCharm, it is way better. It is way more consistent, and this is just from experience. Maybe I'm doing something wrong or something right with PyCharm, something wrong with VS Code, but this is just from experience. If I use VS Code, I don't use the GUI tool, but in PyCharm, you can do that. Well, it is more consistent, and I actually have good experience with it. If I say Control-Shift-P and say maybe virtual, or what was it, Python, create environments, and there are 2 options here. I have venv and conda. If I try to use venv and use an interpreter, it created another folder for me. This is .venv as opposed to env. And so it is created. Now again, I have to say manually when being activated. Now it is activated using a different environment that VS Code created for me. But there should be a way that you could, tweak this, but it doesn't show me anything. Okay, that concludes this video. I will see you in the next one. Hello and welcome back. In this video, we're going to talk about another exam topic, which is going to be about Ansible and Terraform. So 1.6 says explain the benefits of using network configuration tools such as Ansible and Terraform for automating data center platforms. So in this video, we're going to talk about the benefits of each one. We mostly will talk about Terraform because Ansible is pretty well known, and we have more videos on Ansible throughout this course, and we actually configure things using Ansible. With Terraform, we need more explanation and more clarification regarding its association with network automation. And this part, data center platforms, is unnecessary because whatever platform you use, whether it's data center or service provider or whatever, um, the workflow is the same with Ansible and Terraform. These tools work the same way. We just have to use, for example, with Ansible, we have to use the right modules and so on. And with Terraform, we have to use its own configurations. But that is going to be for another video where we actually do something hands-on with Ansible, and we do that a few times throughout this course. And with that said, let's talk about Terraform and its difference with Ansible. So let's first see what is infrastructure as code. It means managing infrastructure configurations in a manner similar to software code, enabling automation, version control, and consistency in deploying and managing infrastructure resources. So basically, you are going to manage and provision and sometimes configure your whole infrastructure, the resources, servers, services, whatever you have through code, through software applications. So this is just a basic understanding or basic definition of what infrastructure as code is. Now, let's talk about Terraform, which is um, an infrastructure as code tool. It's an open source IAC tool for managing and provisioning. So mostly for managing and provisioning, sometimes configuring, but we don't really use Terraform for configurations, and we get to that in a moment. It's mostly used for managing, provisioning, spinning up a whole infrastructure in a few seconds and tearing down the whole infrastructure again in a few seconds. It supports different cloud providers and environments, so it is also cloud agnostic. It doesn't belong to, HashiCorp initially or originally created this application, but now it is open source. It still belongs to HashiCorp, but it works with every other cloud providers. It has plugins and different providers, which you can connect your Terraform code or more of an API call to the different cloud endpoints. Now, let's learn more about Terraform. And here we have some characteristics that we can take a look at in regards to Terraform. Terraform uses HCL, HashiCorp configuration language, for defining the infrastructure as code. So this is the language that we're going to use. And let me put myself here. This is a code snippet that I have here. This is a basic example of using HCL, using a Terraform script to do provisioning and management in regards to our infrastructure. Also, Terraform by default builds a dependency graph. So this dependency graph is something which would determine the order in which resources are provisioned or updated. So this workflow, this operation makes sure that dependencies are managed correctly and changes are applied safely. So we have also execution plans before applying them. If you work with a tool like PyATS or similar tools, or I believe Ansible also has that. So with those tools, we have, before applying these configurations, this script in the standard output, we're going to see some information about whether we want to check, these are the changes that are going to be applied, and whether we want to actually apply those changes to the production environment or actually to pre-prod. It really depends, but it tells us whether we actually want to perform those changes or apply those changes or not. It tells us what are the additions or what are the deletions maybe, and we kind of decide whether it's safe to apply those changes or not. Then we have remote state management. So Terraform by default keeps track of our progress, the state of our infrastructure, and put it inside a state file locally. But also it gives us the option of using it or maybe pushing these state files over to different cloud providers, maybe Amazon S3 bucket, or maybe Azure storage, I think it's called, or even HashiCorp console. So we can also have a backup of our infrastructure state. It also has provisioners and providers. So provisioners are, it's a feature that is going to allow us to run or execute a script when we are deploying or spinning up our infrastructure, or maybe we're doing some kind of provisioning and management. So it would allow us to execute scripts or commands on local or remote machines as part of the resource creation or destruction process. So as we are creating these resources or removing those resources, which is a separate operation than actually running a script, it would also allow us to run some scripts, execute some scripts upon resource creation or maybe destruction or deletion of resources. It has also the concept of encapsulation using modules. So we're going to have these modules which are going to provide encapsulation and code reusage in the future. We're going to have these modules, and whenever we want to maybe do a similar kind of operation, we're going to use those modules so we don't have to write or repeat ourselves again, write the same script one more time. Instead, we're going to use those modules which are pre-written, and again, it provides encapsulation and it removes the need to kind of repeat ourselves and repeat what we already wrote. It also provides life cycle management, which basically means tracking changes that are made to infrastructure configurations. It also it keeps track of the changes that happen over a period of time to our infrastructure. Now, let's see the differences between Terraform and Ansible. So, Terraform is more focused on provisioning and management. When you are first creating or maybe defining the resources for your infrastructure, and it would do that in a declarative manner using HCL, meaning we don't deal with nitty-gritty details of configurations. We don't deal with the actual commands or maybe the actual configurations that are applied over onto our resources. Rather, we do things like defining how many EC2 instances we want to have when we are deploying or maybe spinning up our infrastructure. And maybe we want to do the opposite, destroy or delete every resource that we have, or maybe change the tags associated with our resources, or maybe descriptions. We do it in a bulk operation, which would apply over to maybe 10, 20, 30 resources that we have inside the whole infrastructure. But Ansible is mostly used for configuration. So we actually deal with the exact commands, the detailed commands that are actually applied onto our network devices or servers. And it uses that, or maybe it does that in an imperative style. So declarative means we don't have to define every specific thing or configuration that um, is applied onto our resources. Rather, we define something using HCL, we define the operation at a higher level. But where we're doing an imperative style based configuration, this means we actually deal with the exact command. So we have to be as detailed as possible. For example, if you want to configure OSPF, you're going to have to provide the OSPF commands, the exact command. So this means imperative. Declarative, on the other hand, when we're using Terraform, we don't deal with the actual nitty-gritty details of the commands and configurations. We define or instruct the script to do things at a very, very high level, much higher level than what we deal with in an imperative style type configuration like Ansible. It uses state files, so it means Terraform keeps track of our files and put it in a state file, whether locally or remotely. But Ansible does not maintain the state of configurations. Terraform is used for creating, updating, and destroying infrastructure resources. Ansible supports application deployment, configuration management, and orchestration. And that will conclude this particular video. See you in the next one.